Welcome back to the channel, and today we will explore how to implement list using array, a fundamental topic under abstract data type. Let's begin. And so this is our agenda. We will first understand what ADTs are, then we will about the list ADT, and next we will see how lists can be implemented using arrays. Then we go through basic operations like traversing, inserting, creating, deleting and searching, and then we will discuss the advantages and limitation of arrays. Finally, we will look at with some program examples. So coming to abstract data types, now let's understand what an abstract data type or it's called ADT. Okay, that means ADT means it defines two important things. First is the type of data that can be stored. You know the type of data, right? In float. And second, the set of operations that we are allowed to perform on that data. For example, think about a set ADT which can be stored a collection of integers, and let us perform operations like finding the union of two sets or intersection between them. Okay. So the key thing to remember about the ADT is that it tells us what we can do with the data. Okay, but it does not tell us how those operations are actually implemented behind the scenes. Okay, so an ADT describes the behaviors and rules for working with the data. So without worrying about the details of coding or memory management. So coming to advantages and benefits of ADTs. Now let's look at some of the key benefits of ADT. Okay, one major advantage is that they clearly separate the interface between the implementation. Okay, so in simple terms, this means ADT defines what operation you can perform without showing how those operations are actually carried out behind the scenes. Okay, this means your code much easier to understand and maintain. For example, you can change how an operation is implemented. Okay, maybe you optimize it from better performance, but the rest of your program does not need to be updated because the interface stays the same. So the ADT helps make your program very clear, more flexible and much easier to manage in the long run. So coming to list ADT. Now let's talk about the list ADT. A list is simply a sequence of elements that are stored in a specific order. It's just a sequence of elements. Okay, in a list, each element has a prediction, which is the element that comes before it. Prediction is nothing but the elements come before it, and the successor, which is the element that comes after it. For example, think about the list of students or list of marks. Each item in this list follow one before it and is followed by one after it, right? that maintaining an order. If there are no element in the list at all, we call it an empty list. Understood? So the list ADT help us organize and manage collection of data where the order of elements is a matter. Okay. So now let's talk about how we can implement list in the program. Okay. So basically there are two ways to do this. The first way is by using linked list, where each element contains a value and also pointer that is connected to the next element in the list. Okay, so this way the elements are linked together like a chain. So the second way is using an array based implementation where the elements are stored next to each other in the consequent memory location. Okay, and in our today's session we are going to focus on array based approach. So we can see how the list work when the data is stored in an arrays. Okay, so coming to next, array implementation of list. Okay, so now let's understand how arrays are used to implement list. Arrays store the data in consecutive memory location, that means continuously, which means all the elements sit right next to each other in the memory. Understood? This arrangement allows us to access any element very quickly just by using index number. Okay, like list at index 2 or any index, for example 5. Okay, however arrays also have some limitations because they are static structure. Okay, so static structure, which means once we stored their size, we cannot easily change it later. Okay, so if we allocate more memory than we actually needed, we end up with wasting that space. That is one drawback. And another drawback is that inserting or deleting elements in the array can be quite expensive, because we often have to shift many elements either to right or left to the space, because to make the space or close the gaps. So while arrays gives a fast access and are easy to use, and they have certain disadvantage, we need to keep it in mind while creating. Okay, now let's talk about basic operation we can perform when we use arrays to implement a list. So the very first operation is create, which allows to build the list and fill it with the data from the user. And next one is insert, which lets user to add a new element or in a specific position in the array. Then we have a deletion operation, which moves an element from the list. And next one is display, means traverse, which we go through the list and display all the elements one by one. Finally, there is a search operation which helps us to check whether the particular element exceed in the list or not. So in this session we will going to see how to implement all this operation using C program. So this is some example like memory layout. Here this example shows how data is stored inside an array. Okay, you know, an array keeps all its value one after another in the memory, like lined up side by side. Okay, each place in the array has a position number called that is index number. It starts from 0 and so on. Okay, so this index number which help us to know exactly where each value is stored. Okay, so you can see here it starts from A0 to A5. Okay, so for example, if A of 0 means the first place in the array, A of 1 means the second place, and so on. Let's see, we store a number like in this array A of 0 equals 10, A of 1 equals 20, A of 2 equals to 30. Okay, so these values are kept next to each other in the memory. Because of this, we can quickly find any value if we know its index, right? Index number. So, which makes arrays really fast when we can to access elements directly. But we should also remember a few important points. Array needs a fixed size. So we have to decide how big they will be when creating that array. Okay, and also if we want to insert or delete element in the middle of the array, we often have to shift other elements left or right to make the space. Okay, which takes extra time. For example, like imagine our array looks like this. You can see the diagram, right? Like this. At index 0, we have the value 20. At the index 1, we have the value 10. And at the index 2, we have the value 30. If you want to get the second value, what is the second value here? 10. We simply write the code printf with A of 1 inside the brackets, and it prints 10 immediately. Okay, so arrays are very useful because they store elements in order. That means side by side in the memory. Each element has an index starting from 0, and accessing any element is super fast using this index. But inserting or deleting element in the middle requires shifting other elements around. Okay. So coming to the next, it's a declaration of array. You can see how to declare an array in C program. Okay, so first we need to write as define make size of 10. Okay, so that means this line tells the computer that the biggest size of our list is 10. Okay, which means our array can hold up to 10 elements. After that, we declared that int list of make size comma n. Now, let's break down what this means. Okay, so you know, the word int tells the computer that we are going to store integer number, like whole numbers without decimals. Okay. And next, list maximum size creates an array called list. And it has space for 10 numbers, because you know, right, the maximum size is 10, there we defined. Okay, then the variable n is used to keep track of how many elements are actually stored in the list right now. So even though our array can hold 10 values, we might choose to fill it with only 5 to 6 numbers. And extra count is stored in n. For example, if n is equal to 3, okay, and our list contains list of 0 equals 5 and list of 1 equals 8 and list of 2 equals 12. You know, right, how we declared in that previous slide. Okay. Then our list currently has 3 numbers in it. So declaring the array and using the array, n help us to manage how much data we actually store. Understood? And now let's understand how the create function works in our program. Okay. Hope you all know this is the first operations. It is used to initialize the list with n elements. Okay. So this is some example program. Here the function is called as create, and it starts by declaring an integer variable I. So when we will use for looping, the I could be used. Then it prints a message asking the user to enter how many elements they wanted to add into the list. Okay, so the user types a number and this value is stored in the variable n. Okay, next the program checks if n is less than or equal to the maximum size we have defined for an array. Hope you all remember that maximum size. Okay, so to make sure we don't go beyond the array's capacity. Okay, if the condition is true, it prints another message asking the user to enter the actual array elements. Then using a for loop, it reads each element one by one from the users and store them in the array list at some position from index 0 up to en minus 1. Okay, so for example, you can see here, if the user enters n equals 6, that means n equal to 6, and types a number like 12, some numbers 45, 20, 23 and 75, 89 and then 10. Then these values will be stored in the array list, such as the list at index number has 12, index 1 has 20, index 2 has 10, here you can see, and next index 2 has, 3 has 30, 4 has 40, and so on. So this create function help us to initialize our array with user input and set up with our list ready for further operation like insertion, deletion and search. Understood? So coming to the next, traversing a list. So traversal, as I said you earlier, traversal means simply visiting each element in the array exactly once. That means one by one. In our program, we usually do this with the function called display, okay, which prints all the elements so we can see what's stored in the list. Okay, to traverse the list, we always use a for loop which starts from index 0 and goes up to n minus 1, because the last element in the array is always at index n minus 1. So inside the loop, we can access each element using the index value, like list at 0 and list at 1 and so on. So all the values are in our list, either for displaying them to the user or performing other operation, you know, right? Like searching or checking some values. Okay, so coming to next, insert operation. You know, insert operation allows insertion of element at the particular position in the list. Okay, so inserting at the end of the array is very simple, but inserting at the specific position, it requires generally shifting all the subsequent elements one by one to the right, which is costly. Okay, so you can see the program here. This is a common routine. Now let's understand how the insert function works our array based list. Okay, so the list function starts by declaring three variables: I, data and position. Okay, it first asks the user to enter the data value they want to insert and store in the array. It's called data. Okay, so next it asks the user for the position where they want its new element to be inserted and store that in the variable using that POS, position. That means POS is nothing but position. So the program then checks if the position equals to n, which would mean the array is full and cannot accept new elements. And in that case, it prints a message saying array is overfull. Okay, otherwise it needs to make space for the new element. So to do this uses a for loop that starts from the end of the current list and moves backwards toward the position where the new elements should go. Okay, in each step of the loop, it shifts the existing element one place to the right. After making enough space, the program places the new data at a position, you know, right, POS, POS minus 1. Okay, because the arrays start counting from index 0. Then it increases the count of elements n by 1 and finally call the display function to display all the elements which we inserted. Okay, for example, you can see here. Okay, suppose we have an array with 5 elements and we want to insert the value 15 into the second position. You can see here, right? In that case, that as I said you earlier, the existing elements needs to move to make space. That means the first 50, okay, 50 moves to the next index, which is position 5. 40 moves to the position 4. 30 moves to the position 3. And 20 moves to the position 2. After this 4 data movements, 15 is finally placed in the second position of the array. Okay, so this process makes insertion in the middle of the array. It's quite expensive because it involves shifting multiple elements to the right. Am I correct? So coming to next, deletion operation. You know, deletion means nothing but removing an element from the array. Might be any position, first or middle or last. But the deleting the element last is very simple. If the element to be deleted from any particular position, it requires subsequent elements to be shifted one position towards left side. Okay, so as you all know, deletion removes the list. It can happen at any position. Suppose if you are deleting the last element in the list, we just reduce the count of the elements and we don't have to move anything. Okay, reduce the count of the elements. But if you want to delete an element from somewhere in the middle, here you can see the program. Somewhere in the middle, it gets more complicated. Okay, so in that case, we have to shift all the elements that come after the delete element one position to left to fill the empty space. Okay, for example, if you delete the element at index 2, the element at the index 3 moves to index 2, the element at the index 4 moves to index 3, and so on. So this shifting takes extra time, am I right? And makes a deletion a costly operation in the list is large. So while deleting from the end is quick, and other position requires more work. And finally, search operation. As you all know, search is used to determine whether a specific element present in the list or not. Okay, so the user is prompted to enter the value to be searched. So this is some common routine. The search operation used, the program first asks the user to enter the value they want to find. Once the user provides a value, the program starts looking through the array starting from index 0 and going up to index n minus 1. Okay, n minus 1. At each step, it compares the current element in the array with the value that the user wants to search for. So if it finds a match, it can display the position where the element is found and inform the user that the element is exit in the list. If it reaches the end of the array without finding the element, that means what? the value is not present in the list. So the kind of search is called a linear search because it checks elements one by one in the straight line. Understood? Although it's simple and easy to implement, it can take more time if the list has many elements, especially if the elements we are looking for the near the end are not present at all. So the search operation helps us quickly determine whether the value exists in our array or where it's stored. Okay. So finally, now let's discuss the advantage and limitation of arrays for implementing a list. One big advantage of arrays is they offer very fast access to the elements because random access capacity. Okay, what is random access capacity? This means we can directly jump to any element using its index without having to go through other elements one by one, which makes searching and accessing data much quicker. Okay, and another advantage is the searching. Searching for element in the array is quite easy, especially if the data is stored in the shorted order. Okay, and however there are some limitation. We should be aware of that. The biggest limitation is size of the array is fixed. One it's declared, which means we can't easily resize in its if we need more space. Also, array stored all the elements in the consequent manner, which can sometimes make it difficult to allocate large array if the array is fragmented. Am I right? So finally, insertion deletion operation in the array are quite costly because they often require shifting many elements. For example, inserting a new element in the middle of the array, right, means moving all the elements after the position one by one to the right. And deleting means, suppose if I want to delete a middle element, we need to shift one by one to the left. So these extra movements take time and make array less efficient for frequent insertion and deletion. So while arrays are excellent for fast access and simple data storage, they do not have much important drawbacks too.